So, we've seen that the Grand Coalition, full collaboration between all countries in the world, cannot hold. What I'm going to do now is ask the question whether smaller coalitions, a subset of countries, can get together and agree to collaboratively reduce their greenhouse gas emissions. And for that, I'm going to use the theory of cartel formation, which, as you may have guessed, comes out of industrial organization, and it is about companies banding together to corner the market. But I'm going to apply that same theory here to countries collaborating to reduce greenhouse gas emissions. And the version of cartel theory that we're going to use is due to Claude d'Aspremont, who you see depicted here. And in his version of this branch of industrial organizational game theory, a coalition between countries is said to be stable if and only if it meets three criteria. First, the coalition needs to be profitable. That is, everybody who agrees to collaborate must have a higher welfare under collaboration than in the NAS equilibrium, where nobody collaborates. It needs to be internally stable. That is, nobody who is in the coalition would want to leave. And it has to be externally stable. That is, nobody who is not in the coalition would like to join. Now, immediately, if everybody collaborates, then there's nobody left who would want to join. So the Grand Coalition, the coalition with all countries, is necessarily externally stable. And similarly, if you have a coalition of two players only, then internal stability and profitability coincide. That is, the alternative to having two players in the coalition and everybody else not collaborating, and if one leaves, then you're in a situation where nobody collaborates. That is the NAS equilibrium. So for two players, profitability and internal stability, for a coalition of two, internal stability and profitability coincide. But that's no longer the case with 3 or 4 or 5 players in the coalition, of course. This is still a fairly myopic view of coalition formation, just like free riding sort of assumes like everybody collaborates on what would happen if I were to leave the coalition, but I assume that everybody else collaborates. It's still cartel stability, according to d'Aspremont, is fairly myopic. Every player considers a move assuming that all the others do not change their strategy. But the condition of profitability that is included there does have an element of farsightedness into it. So if you start with a coalition of 5 players, then it's not just that each of the 5 considers what would happen if I leave and the other 4 would continue to collaborate. That is internal stability. But by adding the condition of profitability, it also wonders what happens if I leave and the other 4 also give up collaboration, right? That's the profitability component of cartel stability. But it does not consider the intermediate case. What if I leave and Johnny leaves after me, but the other 3 continue to collaborate? That is not considered, but it is if I leave and the coalition falls apart altogether. That is considered through profitability condition. So how does this work? I'm going to return to the LQ game. I'm just going to consider 2 players because that delivers all the insight that you need. So cost of emission reduction is still quadratic, but I no longer see I have only 2 players, so there's a C1 and a C2, right? And I don't have to use an index. The benefits of emission reduction for country 1 and country 2. There's still marginal impact on country 1, and then the sum of relative emission reduction efforts times emissions for country 1 and for country 2, but instead of a summation sign I just write them out because there's 2 anyway, right? But the structure of the problem is exactly as it was before. The non-cooperative solution, marginal costs of emission reduction dc dr equal to marginal benefits db dr, and we have that non-cooperative emission reduction r asterisk is beta 1 e1 2 over 2 alpha 1, and the problem is completely symmetric, so the same is true for country 2. But of course the indices replaced with 2's. So that's a non-cooperative solution. The cooperative solution is that you take the first partial derivative of the sum of the costs to R1, but C2 does not depend on R1, so that's the same as it was before. You take the sum of the benefits and its first partial derivative to R1, which is the sum of the betas, just as it was before, but your contribution to the problem. So cooperative emission reduction R prime is the sum of the betas, beta 1 plus beta 2 times E1 over 2 alpha 1 rather than 4 alpha 1. And the problem is symmetric, so the same is true for country 2. So what essentially is cooperation? What you do in cooperation is that you work harder. Instead of cutting your emissions by beta 1 over 2 times E1 over alpha, you cut your emissions by beta 1 plus beta 2 times E1 over 2 alpha 1. So you increase your emission reduction by beta 2 times E1 over 2 alpha 1. That is, you do more, you work harder, and how much harder you work depends on how much the other player cares about climate change, cares about the problem, the damages they suffer at the margin. So that is what you offer in collaboration, and the other player in return cares about what their emissions E2 do to you, B1. So you give something, you work harder on emission reduction, and in return the other guy also works harder on emission reduction. So that is the bargain that you strike. So what does this bring? What does this, is this in your interest to do so? Well, what is in your interest is that if you promise to do a little bit more, and in return the other player promises to do a lot more, and if that is the case, the benefits of your action are rather big, but the costs of your action are rather small. And that is in your interest, right? You suffer a little bit higher costs, you do a little bit more in emission reduction, and in return the other guy does a lot more, and you see a large benefit. And if this condition is met, if your increase in benefits is large and your increase in cost is small, then it pays you to collaborate. And that condition is met because the cost function is quadratic and the benefit function is linear. That condition is easily met if you do a little bit more and in return the other does a lot more. But the other player isn't stupid either. What they want is that they do a little bit more, and in return you do a lot more. And if that is true, then their increase in benefits is large, but their increase in cost is small, and they are happy, right? And that is all you need to know about cartel formation, because cooperation works if it works for both, and it works for you if you promise to do a little bit more, the other promise to do a lot more, and for the other player it's the exact opposite, right? They want to do a little bit more, and they want you to do a lot more. But in order for this exchange, or this bargain, essentially what it is, to be mutually beneficial, you have to meet both conditions. And that immediately implies that in a problem as we structured it here, where the cost function is quadratic, therefore an increase in your effort is going to cost, whereas the the benefit function is linear, that is, you need to have a large increase in order for it to be beneficial. That immediately implies that the space for collaboration is fairly small. It's easy to think of a deal that is good for you but bad for the others, and vice versa, and a deal will be bad for you and good for the others, but it's very much harder to think of a deal that is mutually beneficial. The first one to notice this, or to write it up rather, was Cartel, you see depicted at the top the particular application of cartel theory to international climate policy. The honor for that goes to Scott Barrett, you see at the bottom. Now, in that, and another reason why coalition, the profitable coalitions, or the stable coalitions, I should say, are relatively small, why there is so little space for negotiation, is because essentially this is barter trade. This is not a productive economy we're looking at. We're just swapping things. We're not making new things, rearranging input factors to make more. That's not what we're doing. We're just swapping endowments, and barter trade is simply less welfare improving than actually having production and making more things. Now, in this 1994 paper, Scott Barrett actually shows that there are two equilibria in a cartel formation game rather than the one I just described. So the one I just described was really, it's hard to strike a bargain, and therefore what happens is not much emission reduction, not much collaboration. And Barrett refers to that as coalitions that are small but deep, that there is actually meaningful emission reduction amongst a small number of players. That is one equilibrium, but actually turns out there is another equilibrium if you do all the math properly, and that is a coalition that is large but shallow. And with large, Barrett means that most countries collaborate. With shallow, he means that actually what they promised to do in that coalition is not much more than what they would have done were there no coalition whatsoever, were there no collaboration whatsoever. So essentially they're playing Nash plus delta, a tiny little bit more, which of course is almost, from a climate perspective, is almost the same as if they were not collaborating in the first place. So the unfortunate conclusion of all this is that there simply isn't much scope for meaningful collaboration. If there is a large-scale collaboration, then essentially countries are promising to do what they would do anyway in their own self-interest. So I started by saying, well, the Grand Coalition is unstable because of free riding. And then I asked the question, what if there were a few countries that get together? Would that change a lot? Well, not if there are a few countries, right? Because they cannot control the whole problem. And you simply would not have much more than a few countries collaborating, because then the large coalition becomes either unstable or the promises made in the larger coalition are too small to count. So we still haven't solved We still haven't solved the problem of collaboration by allowing for intermediate forms of collaboration, and not everybody collaborates, but some do. So that was it for the game theory. The problem is simple. Greenhouse gas emission reduction is a public good, and providing public goods is difficult without a central authority.